All right, mathletes, here we have discrete numerical data and continuous numerical data. Okay, so remember discrete numerical data is countable type numbers. We're typically not dealing with fractions. Often we use tally and frequency tables to display that information. Okay, and this works when we have a limited amount of numbers in our data set. Okay, so if we have just things like 5 different numbers in here, we can keep a tally. So if we're talking about ages and or maybe scores in a class or something like that, that is typically discrete data. We can also use column graphs to display that information. Make note when it's discrete data and column graphs, we have gaps in between our bars. Okay, we can also use dot plots, which are very similar to our column graphs. Just instead of using bars to be vertical, okay, we use dots. And make sure when you're doing dots that it's symmetric, in the sense that for every time that you go up, the same value for 5 dots is at the same height. Same thing that you would do with your column graphs. Okay, so another way to show that data is a stem and leaf plot, also known as a stem plot. So if this is my data set here, okay, I can put it in a stem plot and organize it so that it's easy to see the distribution. Okay, so usually the stem, okay, in this case is dealing with our tens place. So this scale here is kind of our key that tells us 5 bar 1 is related to the number 51. Okay, so we go through and we have, so this is representing numbers from 0 to 9. This is 10 to 19. These are 20 to 29. This is 30 to 39. And these are 40 to 49. So every time we see a number like 28, okay, we put an 8 in the leaf there, and the stem is 2. We see 47. Okay, we put a 7 there. Okay, and we see 39. So we go to 3 and put a 9 there. A 23 is going to be represented there. Okay, and so forth and so on, and we can get to the final one where it would be 30. So in the 30 column, okay, we end up being there. Okay, so this is unordered stem plot. Okay, and if you want to go, and that's because we just put it in the order that the numbers appeared. Okay, so you have 17 represented here, and then you have 11 represented there. It's not in order. So if you order them, you just organize the numbers in from smallest to largest. So this is 1, 7, 3, 4, 6, 6, 7, 8. Repeating ones that have been repeated. Okay, and we're just ordering them. Okay, so those are stem plots. Okay. Describing distribution of data sets. Okay, so many data sets are going to be symmetric, okay, or partially symmetric. When they're symmetric, they should look similar on one side as they do on the other side. It might not be exact, but it has, if we kind of connect the tops of each ones, okay, it kind of creates a bell type curve, okay, or not necessarily is bell shaped, but it's symmetric on both sides. So you could have all the bars looking like a box. That would also be a symmetric graph. Okay, so that's symmetric distribution. Sometimes our data sets are skewed. Okay, in this example here, we see we have lots of large values, where we have large values, more of them, but they're infrequent. So this graph ends up getting kind of pulled in this way. So we call this a positive skewed graph, or also a right skewed. Okay, so here another diagram, we can see this would be something that is symmetrically distributed. Okay, this is a right side or a positive distribution, skewed. And then we could have numbers that are skewed to the left, where the numbers are pulled out this way. Okay, that's a left side distribution or a negative skewed distribution. Okay, so you might be asked to describe that distribution. Okay, so if we are, there's 45 people in this example that were asked how many times they visited a doctor this year. The results are given in this frequency table. Okay, so if we want to display this in a column graph, okay, I'm going to make sure I have gaps in between my bars. Okay, so for 0, I have a frequency of 6, so my graph goes up to 6. And I draw my column. Okay, for 1, it should go up to 8. So mind you, because we're talking about doctor visits, that's discrete data. Okay, we're not dealing with going to the doctor 1.2 times. So this is a column graph, so I should have my gaps in between my graphs. Okay, I'm going to check these off as I do them. 2 goes up to 9. Okay, so 9 people visited the doctor twice in a year. Okay, there was 7 people that visited 3 times per year. Okay, oftentimes I like to kind of color them in so it's a little bit easier to see. There were 6 people that visited 4 times per year. Okay, and there was 4 people that visited 5 times per year. There was 2 people that visited 6 times per year. And again, 2 people again that visited 7 times per year. And only 1 person had to visit 8 times per year. And this is nice because we can see a more healthy person is visiting less frequently. So we only have a few amount of people that might be not as healthy and visiting the doctor more often. We kind of look at the general shape of this graph. We can see that this is a positive skew. Okay, so we can describe our distribution as positively skewed. Okay, let's look at another example here as we're talking about continuous numerical data. Okay, so with continuous numerical data, often we're dealing with large data sets. Because it's continuous, we have to have class intervals, meaning we have to decide what is going to be the intervals in between our 2 classes, because we're dealing with decimals and numbers with more accuracy. Okay, because of that nature, because of their continuous nature, we're going to make sure that we leave no gaps between the columns. These are called frequency histograms, and they're unique to continuous data. Okay, we might be asked what the modal class is, and the modal class is the one with the highest frequency. So the highest frequency, this here would be our modal class for that graph. Okay, so let's look at an example here. So this is a weight W of 17 pineapples recorded in kilograms. Okay, it's continuous data because we have decimals. Not all pineapples are exactly whole numbers as far as their weight goes. So each measurement was rounded down to the nearest kilogram. So that's probably determined based upon the accuracy of the scale that was being used. Okay, so organize the data into the class intervals. So I kind of, before I start putting them in there, I need to decide what my class intervals are going to be. So looking at my data, I kind of identify what's my lowest and my highest. So I have some really small pineapples, but I also have some that are pretty large. A 4.2 kilogram pineapple is a big pineapple. So I'm dealing with numbers kind of between 0 and 5. So it makes sense to have my class intervals as a value of 1. So that's going to give me 5 different classes. So for our first class, we're going to deal with pineapples from 0 to 1. Most of the time we include the lower bound, so it's greater than or equal to 0, but it's less than 1, and we're talking about our weight. And their next interval, because 1 was not included in the first one, we're going to include it in the second one. Okay, so we got to make sure that we don't always have inclusive on our lower bound and upper bound, because if a pineapple weighs exactly 1 pound, I can't be counting it twice in my frequency table. So here it's included at 1, not included at 2, and that's going to be the class for that interval. Now from 2 to 3, and we're talking about weight, 3 inclusive here, to 4, and then for my really large pineapples from 4 to 5. Okay, so going through, I'm going to identify which numbers belong in each class. So how many are between 0 and 1? So I'm going to cross them out as I go. I get 1, 2 pineapples that are between 0 and 1. Now between 1 and 2. So I get 1, 2, 3, 4, 5, 6. So 6 pineapples between 1 and 2. Between 2 and 3. So I don't include 3, so I'm not going to include that 3.0, but I do include the 2.1. So that's 1, 2, 3, 4. 4 there. And then between 3 and 4. So now I am going to include the 3, so that's 1, 2, 3, 4. Okay, and how many do I have between 4 and 1? Well, just 1 here. Okay, I like to cross out so I make sure I don't leave any ones out. And then I also like to double check. I know there's 17 pineapples, so if I add all these up, I get 10 plus 4 and 2 is 6, plus 1 more, that's 17. So I've accounted for all of the pineapples in my list. So now I'm going to build my frequency graph. Okay, from 0 to 1, okay, I have 2 pineapples. Because it's continuous data, it's a histogram, so my columns need to be right next to each other. So 1 to 2, I'm going to be 6. I'm going to use part of that graph to finish that left side. Goes up to 6, and I go over. Okay, again, we can kind of shade these in as such. From 2 to 3, I have 4, so I'm going to be 4 there. Okay, from 3 to 4, again, I'm 4. Okay, and 4 to 5, I have 1. Okay, so I've drawn my frequency graph. The modal class. Well, which class is most frequent? So the modal class is from 1 to 2 kilograms for my weight of my pineapples. Okay, that concludes our notes for tonight. Please highlight any questions you might have and bring them to class tomorrow.